So let's switch a little bit. Maybe.
Am I off?
And we're going to talk about how we roam. And one of the things that our local switching does for us that's good. And we'll start off with this. The drawing is up there, but I've actually put it up here. I'd rather whiteboard it and talk about it. And if we've got a client, we'll call it client A. And over here we got client B. If A is trying to talk to B, typically his traffic has to go to the AP, through the switch, to the wireless controller, back to the switch, to the subnet. It's got a lot of traversing to do to get there. And then on the way back, it has the same path to flow through. The real problem is when client A moves over to this AP and he wants to talk to B. His root controller is WLC1. So traffic goes up, across, over, up, down, across, up, back down, and over. Getting messy, I know. And the traffic's getting messy. If you're local switching, traffic goes from A to the AP to B. I ask you, what's a little more efficient? That's the ideal performance orientation that we get. That's why we continue to drive the local switching piece. That's just one of the reasons. It's huge, and it means a huge performance difference between the way we do it and the way some of the other vendors do it. The other one, and Jay mentioned this already, so I'm not going to spend much time here, is the dynamic automatic load balancing and our beam band steering. The ability for clients to, so we suggest they move to 5 gig. And as Jay talked about, one of the rationales about having the 5 gigahertz cell size, when you think of it as a cell size, be in similarity to the 2.4 gigahertz cell size is because we want to push those 2.4 users to 5 gig as much as we possibly can. And so designing that 5 gig radio so the cell sizes were fairly concentric between 2.4 and 5 gig allows us to do that much easier. So the band steering will allow us to push those clients up if they can. By the way, what I heard today was the new Apple iPhone 5 is 5 gigahertz capable. So that's great.
So you're pushing all of the clients to 5?
It's going to depend on how many clients are there. We'll push them to 5 unless there's nobody at 2.4. I mean, we're not going to push everything there and have to leave it empty.
Clients count based on the airtime used?
It's based, it's
based on a number of factors. The number one factor, of course, is the client count. We put client count, we try to go back and put.
Sorry, can't hear you over here. Speak a little
Speak up.
louder.
It's based off of the client count. That's one of the primary parameters that we look at, is the number of clients. So because we want to load balance them across the two radios.
okay. Let's get inside our network. I'll move over to this drawing here. And this will probably get messy again. We've got in the cloud, in our cluster, we've got 4 controllers. WLC, by the way, wireless LAN controller, wireless LAN access point, and M is wireless LAN management. That's how we break it into those 3 groups. So we've got in our cluster, I put 4 controllers in here. Now where are they physically located? Anywhere on the network. They can be stacked, same cabinet. They can be spread across different buildings as long as they're on the same network. That's what's key. I've identified one as primary and one as secondary. What does that mean? That means in the management, I put a checkbox next to one and next to the other. All these controllers are grouped together. And when they group them together, I manage them as a single controller. I can have multiple groups, but the controllers are under a cluster, and I manage that cluster like it's one controller. So whether I have 1 or whether I have 32, I'm managing one entity. That makes the management much, much easier. The only thing that we require is that you run the same code on them. And guess what? You don't have to worry about that. The cluster worries about that. As long as you have the right code on the first one that we call the seed, the rest of them will come up to par. You make a change in your configuration, it gets distributed among all the controllers in the cluster. I'll talk about code upgrade in a couple of minutes. You just have to simply take and identify put an IP address in them and identify the IP address to the management routine, tie them into the cluster, and that's the way you run it. It's very simple, actually, when you think about the steps to get it done. Once you've done one, the next one becomes very easy to put back together. So how do we manage it? We manage it as a single entity from there. The APs, when I plug an AP in, I don't tell it what controller to go to. The cluster determines what AP is going to go to what controller. So that's different ways we do that. Now let's say I've got my 4 controllers, or I've got 5 showing up here, so I need to add a 5th one. So I'm going to add WLC5 in here. And this controller can be any, and by the way, they can be mixed models. Same code, mixed models. So I bought a new controller out of, Joe's shack over here, whatever the partner name is, wherever I bought it. And I'm running 7.7 in these controllers. This came in at 7.5. I got to go upgrade it. No, I don't. I give it an IP address. I tell the management routine up here, ringmaster, that's what this stands for, that he belongs to it. I plug him in. The code comes down. The configuration comes down. And he's ready to rock and roll. Oh, and by the way, the APs, since I've got AP spread across 4, they're now going to rearrange and spread across 5. Fewer APs per controller. Dynamically. How easy is that for adding a controller? I want to add an access point. I'm going to put it in the guard shack out by the front drive. I've got an Ethernet cable out there. I plug my access point into the Ethernet cable, my new AP. Plugs into the network. I tell the management system that this serial number is part of my network. It shoves it the proper code. It assigns it to the network. When it does that, it's going to say, by the way, we'll call this AP number 10. So AP 10, it sets up his information on a controller. It'll also duplicate that information on another controller. It backs that information up. So 2 controllers at any given time have that AP's information. Anytime an authentication or a management traffic comes in, it hits this controller. If it's data traffic, it hits the network and goes where it's supposed to go, to the destination. So adding an access point is as simple as read the back of it. Got to put your glasses on for it, though, because they're small. Read the back of it and put it in to the management system, plug it in, and rock and roll it. Ready to go. That's simple. Now, you don't have to assign primary. You don't have to assign secondary, tertiary controllers for it. Those get assigned dynamically. Now, what happens?
Excuse me, do the WLCs all have to be in the same subnet?
No. They could be. I can have one in the building across the street, one in this building. They got to be on the network. Are there any stipulations around that, Tim?
There are sort of the detection, the failover detection times. So we have some tolerances that we recommend. So if customers are, say, trying to deploy redundancy across data centers, there are some timing constraints in there, just configuration knobs.
Yeah, you might not want to do it in Europe and in the US, but it'll work. Okay, so what happens when this controller, well, I'll use this one, this controller fails? And I know my drawings are getting a little messy up here. I never claimed to be an artist. When it fails, we can pull it out, we can plug a new one in, simply telling from the management system, remove this IP address, put this controller in, and plug him back in. He comes back online. This AP, when I have a client attached to him, so my client talks to this AP, because there's authentication going on, this controller sets up the client session, and this controller copies it to the backup controller, the session. So if this controller fails, all this client's information is copied elsewhere in the cluster. That failover time, because I'm sending traffic through the controllers, is somewhere in the 200 to 300 millisecond maximum time if that controller fails. If I'm locally switching, I can be on a voice call. This is a voice client talking to this AP. If this controller fails, my voice call continues. My video will continue. We're going to demonstrate that video.
What if you do the layer 3 roaming?
If I roam layer 3,
Yeah.
the client here is going to send it to the network and send it to the appropriate destination address.
So if you cross the subnets while still having the active session, what is the data flow then? So you support inter and intra-mobility through the controllers, layer 3 roaming, all on the access layer.
Yeah. Is there any, I don't think there's any stipulation there at all.
Yeah, no, there's sort of different, sort of two answers. There's when we're local switching, so when the APs are forwarding traffic directly,
Yeah.
APs have awareness of the VLANs that they're attached to. So in your layer 3 case, if you're on AP10, the subnet that is where you start, say you roam to an access point that does have VLAN 10 on it as well, then you're just locally switched right there.
Yeah.
If you roam to an access point that doesn't have that VLAN present, then the local switching capability will tunnel to a WLC that does have that
So
VLAN
then you
present.
have to go through the.
So then you go through the WLC.
Okay.
There is always a backup path in the network, so that in the event that that controller does fail, the AP is
Yeah.
pre-plumbed with sort of with a redundant path in the network.
Okay.
So and that's kind of the overlay answer. So we're always tunneling that.
Yeah,
the redundant paths are always
that's pretty
available.
much how everybody else does it that does distributed data plane as well. So
Mhm.
you have features where you still have to go to the controller, right?
Yep, and it's sort of it's I would say it's more of sort of operational simplicity. If that network isn't available at the port where your AP is plugged in, we've got to get it where it's supposed to go somehow. So we tunnel that to kind of the most optimal device in the network. That's either another AP, that's another WLC. It's with the cluster, we know where our VLANs are, where our router attachments are. So tunnels are sent to the sort of the most optimal place in the network.
So if you don't mind, I'd like to interrupt just a little bit.
Sure.
So my name's Tash Hepting. I'm actually the Director of System Test and a longtime trapeze artifact. So I think I know a couple of things you're trying to get at with the questions and wanted to kind of jump in and give some answers. So in addition to tunneling to the controllers in the fallback mode, it can also tunnel to APs. So we actually do AP to AP tunneling and layer 3 mobility in addition to controller-based, in addition to local switching-based. A lot of the competition talks about doing local switching as well. And one of the key differences between how we do our local switching and how they do their local switching is there is an extensive list of caveats for features that do not actually work when you local switch.
Yes.
Our caveat list is incredibly small.
Do you have that?
The only one I can think of off the top of my head is layer 2 restriction.
L2 restrictors you can work
Yeah.
around with an ACL.
So we can do proxy ARP for the clients while we're local switching. We can do ACLs. We can do captive portal as well as external captive portal redirect for local switching clients. Just to name some of the harder cases. And then furthermore, you don't have to decide to have your entire system local switched or overlay. What Tim was talking about is that VLAN awareness at each AP means that as the user is roaming around the system, it's making decisions on the fly. So the user's on a local switching AP, roams to another AP that's not local switching and has to fall back to an overlay mode. That's transparent. The user doesn't notice anything. And then again with the cluster, and you've got your redundant data paths from the AP. On the fly, your kind of data path redundancy or resiliency in the event of a failure is kind of flopping back and forth between whichever mode makes sense. And you're varying from your worst case scenario if somebody kicked the power cord out on a controller. Your worst case scenario is going to be less than a second interruption, frequently, 1/10 of a second interruption, to best case scenario if the traffic's being local switched, no interruption.
So Juniper is extremely strong at the carrier market, right, as a company. How do they feel about the local switching?
I don't think they have an issue with it. We're talking about locally switching inside the
Yeah.
Company.
So if you do the data offload or whatever, and the carriers, they do prefer all the traffic to be tunneled. So what do you see in your experience? Do you have any carrier deployments? What is their perspective on it?
So I was recently at an international carrier site who's doing some extensive Wi-Fi offload work, and they are actually thrilled with local switching, particularly being able to use local switching with the external captive portal capability. So they've got a network with about 8 of our largest controllers deployed, about 2,200 access points, and their primary competition in the region is talking to us right now because they've been doing metrics on the competition's network versus their network and
So
are
they're
envious.
appreciating capacity more than the control they would get by
Well, no,
by tunneling.
they still have the same level of management and control for the system. They don't have the same amount of, say, service level awareness of what's going on with the data path.
Yeah.
They don't mind that because they don't actually want to bottleneck stuff through the data center so much. They're partnered with somebody else for their metro network for carrying the backhaul back, and they're actually happier to have all of that data go directly and have a system that's sophisticated enough to actually hook in and do the captive portal and redirect over to their back-end system so they can do their own authentication and billing stuff off of that.
Because you have 10 gig ports on the controllers,
Mhm.
right? So that is just if somebody just really wants to do it in case, because obviously if they stick to what you preach, you don't need 10 gig.
Sure, and I've, so prior to my tenure in QA, I was also managing TAC back in the trapeze days for North America, and what we've seen is that it's really hard to predict which architecture is going to fit for which customer. I see most people in enterprise networks actually prefer the straight overlay model because they want to have a minimum of configuration and modification on their existing network. Just want to throw wireless on top of it and not really have to worry about doing anything with the intermediate network. So they absolutely love to have the full overlay model. Other people, it depends on what they're trying to do. Some of them like local switching, some of them like overlay.
Speaking of the ease of integration, do you have any integration with your switches? So the customer, if they plug in the AP and do the local switching, so they do not have to manually do the trunk ports on access layers or something like that? So the ease of integration as you're talking about?
Not yet.
So yeah, in a larger Junos discussion, there's the Junos APIs, the Junos script functionality is extremely rich and in the platforms that drive the EX and the SRX. So problems like that are good targets to solve with Junos scripting. So we have stuff that will automatically provision a port based on the LDP announcement that an access point makes. So you can do things like your AP management VLAN. You plug in an AP, the EX figures it out, automatically provisions the port, the AP boots up. So things like that we've solved today with Junos scripting. More advanced cases, it's not today, but it's definitely something we're looking into.
Let me talk one other thing here. When we start talking about failure modes, we start talking about these redundant APs. I want to talk a little bit about, is there a slide for that? I think there is. I want to talk about that evil word again, licensing. Licensing is a nightmare. I hear customers, when I was at the other employer, people hated it. You get the same impression from your customers or as customers?
No,
No
everybody loves the
That's the solution.
No licenses.
Yeah.
So let me talk about how redundant controllers and licenses cost a lot of money. Should be apparent to everybody. You've got an AP, we license it for 256 APs, and I picked 256 simply because it doesn't try to find the right number to make it the most optimum, good or bad. 100 APs here, 100 APs here. They'll load balance 100 APs on each controller. If a controller fails, I've got enough licenses on either controller to pick all 200 up, right? Simple math. The downside is I'm paying for 512 licenses. When you put the controllers in a cluster and you enable something that we call high availability, what we do is we license each controller for 128 for these numbers. 100 APs will attach to one, 100 APs will be on the other. Because the high availability communicates between the controllers, if one fails, the other controller will assume those licenses, providing there's enough headroom in the controller. That's a caveat, providing there's enough room to do it. But what it amounts to is, I only bought the licenses I needed. I didn't buy double my licenses or more just because I need to do that. So that's a great key feature. I want to talk about one more thing, and then I think we're going to break into a demo here. I'm looking at my sheets. Yep, right after this one. And this one I used a pretty slide on because I just kind of like it. This is one of the things that I was thrilled to death with when I came over to Juniper. To upgrade software live in a working system while users are on the network. When we do it, we bring it into Ringmaster, and we tell Ringmaster we're going to drive new software, we're going to push the deploy button and shove it out. What it does, it hits the seed controller, and the seed controller says, I've got new code. Secondary controller, you take over for me, and I'm going to load new code. He upgrades his code. When that's done, he'll tell the secondary controller, I'm in charge again, here's the new code. Load the new code. And then when he's done, it goes and hits each member. Well, what about the APs? The code on the APs comes from the controller, right? And 9 out of 10 times when you upgrade controller code, you're upgrading AP code. Well, the first thing we do is we upgrade APs that don't have clients on them. That's easy enough to do. Once that happens, we'll go to the APs and we'll actually drop the power. To the client, he thinks, hey, I'm roaming. And he hands off to the other AP. Now, there's two caveats here. It only works if you've designed a system with that overlapping coverage, which if you don't design a system with that, you're probably either in a warehouse or you didn't design it right. Those are at least my opinions.
Didn't follow your site survey book, man.
I'm sorry?
They didn't follow your site survey book.
They didn't follow my site survey book, that's right. The other caveat is I'm that guard shack out there in the middle of nowhere, and there's only one AP. I have nobody to hand him off to. So it's most users, in most cases, will never be affected. They'll continue to click right on through. And that is one of the things that I think is huge in terms of managing and operating a network.
Could you download the code to the controllers and have it go through its staging on each of the controllers that are inside the cluster, but have it hold off on doing the APs until a certain time later? Like say you wanted to stage the code early in the day and then have it push to the APs when you know there's going to be less people online, like say midnight.
I'm going to look at
So
Tim
that's-
and ask.
Yeah, so usually, so Ringmaster, the management tool, has this notion of scheduled activities. So in that, the hitless upgrade cycle, kind of the first person, the first domino that gets pushed comes from Ringmaster. So you would schedule kind of the whole upgrade cycle for, say, midnight, and then, code would roll out and the process would start at that point. It's kind of, once it starts, it will run to completion on the upgrade cycle.
Okay. And then the AP is rebooting itself after it gets its code to roll into the new code, or is it an inline flip of the code?
The AP will need to reboot to load new code. In the event that the AP code has bootloaders and this stuff, there's typically a reboot involved.
And since those users that were on that AP have been moved to the adjacents, not a big issue. Okay, with that, Tim, I'm going to have you come up and start our hitless failover demo.
We'll do this real quick. I think we're running short on time.
Yeah. All right.
So we'll you try to figure out with the iPads who you're actually talking to on the other side.
Tim, these are close to. Where do you
Everybody
want these
gets an
Yeah, unfortunately, you don't get to keep these. Like that would be really cool, but yeah, sorry. Wherever. I just need
Put
to
them right here in the middle.
Right in the middle. That's good. So by way of,
Yeah, but I need to keep, these two have special things.
I just need to remember where those ones are. That's all.
Does everybody have one? We're good? All right. No, here, take one. And I'll take the other one.
By way of introduction, just so what we've got here, this is sort of our kind of our network in a box. So the AP that Jay was talking about, the AP that Jay was talking about is the 532 we've got here. The 322 that Jay also talked about is here, and one of the ones that was floating around, the 522 is down here. Also in this demo box, we have a pair of WLCs, so WLC1 and WLC2 on Bruce's picture. We also have the other components of the CDBU portfolio that, when we're demoing this, we like to sort of showcase how the WL integrates with the other components in the Juniper portfolio. So our WLCs are running against the smallest EX that we have. The SRX is doing our routing and application enforcement function. Then we have a small MAG appliance, which is basically our policy engine. So kind of all that's rolled up in this this little network in a box. Everybody here is sort of being artificially forced, so we're fixed load balancing, running off the 532 there. And if this demo goes the way it's supposed to, it will be probably the most boring thing you've seen all day. So we have our, this goofy little tool shows us our two WLCs. In Bruce's picture, this is our primary, this is our secondary. Green lines indicate kind of the active connection. So when Bruce was talking about here, every AP in the cluster maintains 2 active connections to a WLC. These are coordinated by the primary seed. So as network load changes, the primary seed can just shuffle APs around, both primary and secondary connections, kind of as needed. So right now we see, this is the AP everybody's on. Primary goes to WLC1. Our backup connection is on WLC2.
Now Tim has forced those, by the way, to be on one AP and one controller.
Typically what we would see is the primary seed would take the 3 APs in our network and would balance those among the WLCs based on license count, based on platform capabilities, based on network load. So we would see these normally more distributed. For the sake of the demo, we force it all to the primary one. So we see all of our clients here, a bunch of guys on this one. What we'll do is we pull the power on our primary seed. So network just flipped over. Hopefully all your calls stayed up. I'm guessing maybe a couple of video artifacts. We lost a couple of frames. This will update in a second, and everything just flipped over to our secondary. Network stays operational.
Anybody lose a video?
Anybody lose anything? No? Okay, then yeah, that's how it's supposed to work. As designed. All right.
Yeah, it's supposed to work that way.
So yeah, that's kind of the failover.
In this case, we like it boring, right?
Yes.
Exactly.
So what is a little different about in this demo, we're not actually using the local switching functionality. We find the demo works a little bit better if you lose a little bit of traffic. Typically, we do it with voice, so there's a small click. Video is easier when there's a bunch of them. So there is actually data tunnels going from the AP to both WLC and WLC1 and WLC2. So we actually had a complete failover of the data path as well. So. All right.
Okay. What is our next demo? Maybe we roll this. Demo, Ringmaster, lifecycle management.
We should probably.
What app is that?
Yeah.
Oh yeah, sorry. That's the the application we were using is Polycom is a big Juniper partner for a lot of our UC applications. So we're using their Real Presence platform, I believe, without the server component. It's really just point-to-point calls, but it works well.